Hello, 6i, and welcome to another edition of 6i Science. You'll notice it's pretty dark today around me because everyone's sleeping in my home. But you can definitely still see me and you can definitely still see the screen. So let's get this started. And I will be talking a bit about the comments that some of you have made in the lesson about what goes up must come down, about gravity. And I'll also go through a few selected questions at the end of the lesson. Okay, so let's get started. And the first one we looked at was looking at this toy called the kendama. So you catch a ball in a cup, okay, and we compared it on Earth and in space. Okay, so Muhammad actually observed that the user on Earth has to catch the ball pulled down by gravity. And you would think that this is easier in space because there's no gravity pulling on the ball, but actually it's almost impossible. In fact, Muhammad says it's impossible to do so because even if you catch the ball, there is no force of gravity to make the balls pull the ball to stay down the cup. It just floats away. Okay, so that's the first activity we looked at. Next, we looked at playing soccer in space. Okay, so we observed that on Earth, okay, you can kick the ball up. Chandler observed that you can kick the ball and it will fall to the floor. Okay, so let me make this video bigger. Okay, so if I were to kick a ball on Earth, I kick it up. Okay, once I kick it up, gravity will pull the ball down. Okay, gravity pulls the ball and it falls down. But in space, if I kick it up, okay, if I kick it up, it just floats. Okay, it just floats and floats and floats, and it just floats away. So, like Muhammad says in his comment, the ball will just float in the direction that it was kicked. Okay, there is no force to pull it down. So the point here is that you need a force to change the direction of a moving object. Okay, so on Earth, that force that changes the direction of the ball is gravity pulling it down. And of course, there's friction as well. Okay, there's air friction on the ball. Okay, so let's take a look at the next example. We looked at the video of wringing a towel in space. So Charlene mentioned that when you squeeze the wet cloth, when you squeeze the wet towel in space, okay, there is no gravity acting on the water. Okay, so the water actually stays here. Nice big fat chunk of water stays here, and there is no gravity to pull it down and to make it drip. Okay, so Aisha also mentioned, yeah, there's no force of gravity to pull the water down. Okay, next, we look at the example of the anti-gravity gun. So you have what Amanda mentioned, that you can make things float. The difficulty or interesting thing is how do you the minus is how do you unfloat things, right? Because if you don't unfloat things, they'll float forever. Okay, and Icha mentioned that uh, yeah, if we are floating, okay, how do you get to the ground? Okay, so again, there's no force of gravity to pull you downwards. Okay, other comments. Okay, so Aisha mentioned that you can make everything float. Okay, and the interesting thing is, if you make everything float, okay, so you take your anti-gravity gun and you start shooting different things around you. So I shoot a truck. Okay, the truck has no gravity pulling on it. It starts floating slowly away. I shoot a bus. Okay, the bus starts floating slowly away. What happens if you hit these objects? Okay, so what happens if you're running, okay, and you hit a floating truck? Okay, so I say again, what happens if you have a floating truck in front of you and you run and you hit the floating truck? Will it still hurt? Well, yes, like Aisha said, because it has the same mass. Okay, a truck has a lot of mass. There's a lot of matter, a lot of matter that goes into a truck. Okay, so if you hit it, it would be pretty painful. Okay, it would be really dangerous. Okay, so on that note, I've put the link to a video of a movie called Ender's Game below. Okay, and as you watch the video, think of this question: does it hurt if two people collide in space without gravity? Okay, so in this video, there's no gravity, but they still have mass. So when they collide with each other, does it still hurt? Watch the video and find out. Okay, next. So we move on to magnets. Okay, now, magnets, okay, so This one, more than half the class got wrong. Okay, so I want to take a look at it. Okay, so you have two bars. One is called AB, one is called CD. And what we notice about AB is that AB always comes to rest pointing to north. Okay, so what is something like this called? It's called a compass, right? It's called a compass. Okay, so AB actually acts like a compass, and we know that compasses are made of magnets. Okay, so we know that AB is a magnet. Okay, so this bar is a magnet. Now let's look at CD. Okay, CD is made it comes to no definite direction. Okay, so it does not act as a compass. But I think most of you would have missed out reading the question. Another bar CD made of the same material. Let's look at that again. CD is made of the same material as AB. That means that if AB is a magnet must be made of a magnetic material such as iron or steel. Okay, so a magnet must be made of a magnetic material that got magnetized, maybe by stroking, right? Stroking was one of the ways that you magnetize materials. Okay, so AB is iron or steel, and CD is the same material. So that means CD is also made of a magnetic material. Okay, so if AB is a magnet and CD is a magnetic material, okay, you can have A attracting both C and D. Okay, because C and D is a magnetic material. All right, I hope this explains this question. Let's move on to the next question. Okay, so in here you have two identical blocks that are being pulled up from a ramp. Now, the most common wrong answer that I got was B. Okay, so quite a few people mentioned that block X has a greater force of gravity acting on it than block Y. Okay, block X has a greater force of gravity acting on it than block Y. Now, this is false. Why? This is false because the two blocks are identical. Okay, the two blocks are identical. That means they have the same mass. Okay, they have the same number of kgs. Okay, so this could be 2 kg, X will be 2 kg, Y is also 2 kg. Okay, so it's the same mass, and they are both on Earth, right? So anywhere you are on Earth, you will have the same force of gravity pulling down, okay? Assuming it's the same mass. Okay, in this case, they are the same mass. Okay, so everywhere on Earth, 2 kg is still 2 kg, assuming it's 2 kg. Okay, so if this block, even if I bring it higher, okay, if I bring it higher, there's still the same force of gravity pulling down on it. Okay, so that's why B is wrong. Okay, let's take a look at the last question. Okay, so you have a spring and you have blocks pulling down on the spring. Okay, now uh, how do the blocks pull down on the spring? How do the blocks push down on the spring? The force that is causing them to go down is gravity. Okay, so the larger the mass of the block, the larger the mass of the block, the more force of gravity there will be pushing it down, right? So if it's 2 kg versus a 5 kg block, okay, a 5 kg block would compress the spring more. It will have greater gravitational force pushing the spring down. Okay, so if you look at the chart here, okay, um, block W causes this length of the spring to be shortest. Okay, shortest means it is the most compressed. Okay, shortest means it's the most compressed. So if it is the most compressed, that shows that block W is the largest mass. Okay, it's the largest mass. It has the most gravitational force pulling down on the block, and that makes it the largest mass, which has the least mass, smallest mass. Okay, so the smallest mass would have the least force of gravity pushing down, so just gently pushing down the spring, and the spring would have the longest length, right? That would be Y. Okay, so Y has the least mass, the smallest mass, and it leaves the spring very uncompressed. Okay, so W, so from smallest to largest, smallest would be Y, okay, and the most compressed, the largest mass would be W. Okay, so I hope that this explains the spring question. And we've come to the end of the questions. I hope it has helped to make a bit clear, make it a bit clearer for you. But if you still have questions that remain unanswered or are still not sure, post in the comments below, and I will try my best to help you. Okay, so post any unanswered questions or questions you still have in the comments below. Okay, this is me tuning out for now. Bye, 6i.